speak it properly. I am working at the University of French Polynesia, at the Geodesy Observatory of Tahiti. I am the head of this observatory. And this talk is an echo to the wonderful talk we had this morning about the catastrophic event in Japan, but as seen in some way from the South Pacific. Oops. Maybe this. So first, I am starting where is French Polynesia, because a lot of people are making confusions. We are not in Haiti, but in Tahiti. No, I had several times. Okay, so we are here. Okay, so where is that? So we are exactly in the middle of the Pacific, in the middle of nowhere. And Tahiti is a very small island. So here you have, okay, this area is belonging to France. This is an autonomous territory of France. It's about 2,050 50 kilometers wide here. You can see it's quite large. So here you have all the islands that are making of French Polynesia. There is about 120 islands all around. The main island is Tahiti, is here. And we have a 5 archipelagos. This is a society archipelago. Here we have the Tuamotu archipelago. We have the Austral archipelago and the Marquesas archipelago. So Tahiti itself is here. It's a double island. About here you have the scale, 5 kilometers. It's about 30 kilometers wide. Yeah, and with the tiny island is Tahiti. And there is about I would say 300,000 people in French Polynesia, and at least 2/3 are on the Tahiti island itself. Here we have the complex. We have three islands. Moorea, Tahiti, here you have a small atoll, Tetiaroa, and you know that all these islands, like Hawaii, are created by hotspots, and here is the location of the current hotspot with an active volcano here that is Meetia. Here you have a geologic section of Tahiti. As I said, it's an extinct volcano. Maximum altitude is nearly 2,000 meters. And all the people are living on the seashore. There is no people inside. So it's a rainforest, mainly a rainforest. So, as I said, I am managing the Geodesy Observatory of Tahiti. It's a small observatory. There is 6 people working to observe at the observatory. And my lab is around 20 people, mostly on remote sensing and geosciences. And so we are operating a laser station to observe satellites in collaboration with NASA and the French Space Agency. We have several GPS stations, a DORI station, a network of tail gauges all around French Polynesia. Here we have the location of the tail gauges here. And we are adding tail gauges in the Tuamotu archipelago here, and we have also a chiffon gravimeter. And we probably expand this network with a VLBI antenna quite soon. We expect to have it within 2 or 3 years. So here you have the laser firing at night. So we are observing LAGEOS and low Earth orbit satellites. We are the only station in the middle of the Pacific. This is another instrument, of course, a GPS. We had quite recently, we have just to find a new one, an aeronet measurement for aerosols. Here you have the DORIS antenna. And as I said, we have also some seismometers pertaining to the French Radio Surveillance Agency, the CEA, and we are observing all the earthquakes along the Pacific Rim, and of course also some gravity changes with the chiffon gravimeter. I already said that we have a network of tailed gauges. This is the tailed gauges in the main port of Papeete. This is pertaining to the Hawaii University for the tailed gauges itself, but all the GPS systems are under responsibility here. And I am now going to the main topic of my talk, that is to say the observation of the Japanese tsunami. And of course we didn't saw 30 meters waves in French Polynesia, but we had still up to 4 meters in some places. And 4 meters is of course for a very large number. We have to understand that in French Polynesia, of course, as I said, this is not Japan. We have only 300,000 inhabitants. Very often on this small island, we have only a few handful of people. In some island, maybe 100 people per island, you can imagine. So that nearly 2/3 of this island have airstrips. Very tiny ones, but we are going from one island to the another one by using small planes. This is the only way to be able to deal with the very large extension of this area. It's as large, nearly as large as the US. So here you have the wave from the Japanese earthquake, late March, in the Marquesas. And here you have the effect of the waves, so we have a second boat here. We had nearly 4 meters, as I said.
Excuse me, what time that tsunami wave arrived here?
I don't remember. We had the alarm ran at about 4 a.m. in the morning. I was sleepy at that time.
I think from your sea level.
Yeah, I have the. We will see. I think they arrived 7 or 9 hours later. Just the time to cross the Pacific. But we will see the time if you want to interested. I don't remember exactly. It was around 10 or 11 a.m. in the morning. I'm sorry. Okay, so another nice picture. Okay, this was the precedent. Okay, so you can see that we had the harbor was nearly depleted of water. At the low of the tsunami, and thereafter at the height we had a nearly inundation of the same harbor. This is the River harbor in the Marquesas, as I will speak a little bit more just after this picture.
Excuse me, how high is the tsunami wave?
As I said, nearly 4 meters maximum. 4 meters maximum. Yeah. Another typical picture of the tsunami. Of course, we were expecting the tsunami because we had an alarm ringing, so everybody was sent to the hill. Nobody was killed because we had several hours of advice. Sorry. So you could, of course, you know about the origin of the tsunami. I will not comment on it. Here you have the duration, the tsunami propagation time as seen from Tahiti. So as you can see, in fact, we have 3 major problems. One is the presence of the trench around Japan and the north of the Pacific Rim. We have a problem with the Chile trench here. And the most important for us is the Tonga trench. That is only at 3 hours flight, tsunami flight, I would say, from Tahiti. So we had, when the tsunami from Japan arrived, we had nearly 10 hours to prepare. We had the alarm from the earthquakes records in Papeete. We have always a computer on duty with a seismometer, so the computer shows the arrival of the seismic waves. So it's just a time for the technician to look that it is a real alarm or not. We computed the magnitude of the earthquakes in a few minutes, and all the authorities were around about the arrival of the earthquakes, and they decided to sound the alarm just before dawn. So we have several problems in French Polynesia. Here you have the level of risk with respect to the tsunami. As I said, we have 5 archipelagos, but they are not equivalent in terms of risk. This is because when the wave or the tsunami is coming, all it depends about the depth of the ocean. And in some places, for the Tuamotu, we have a very, very large depth with a small atoll isolated. So there is no problem at all. But on the Marquesas Island, all these islands are sitting on a plateau. And the plateau is acting like an amplifier for the wave. So we have here a very, very, we can observe very, very important tsunami. And we have records of tsunami waves up to 20 meters in this area. Another spot with very high risk are in the Austral island. So I will show you some examples. So just the only warning systems that we have are these alarms. That is to say, on each island, on the city hall, very often, we have sirens here. This is the city hall of Ivaoa, Wapu in French Polynesia. So they are sending the alarm by phone call, and the alarm is sounded. And when you are hearing the alarms, you know that you have to go to the hill. So just to make an illustration, of course, we had a very nice presentation this morning about the Tohoku Shio Teioki earthquake. I think this is a complete name of the event. You know about the casualty, a lot of people were killed, and still a lot are missing. This is the propagation time as computed by standard software that we have also in Tahiti. This is the maximum tsunami height computed 23 hours after the event. And we were very concerned because all the energy is radiating perpendicular to the earthquake, and we are nearly on the beam. So we were not sure about the events in French Polynesia. So just this is the same map as before. So we will go and look at the Society Island right now, because in Tahiti, as I said, about 50% of the population of French Polynesia are in Tahiti, so it's quite important to have a good prediction and a good alarm system in Tahiti. Yeah, the Tahiti Island itself. So this, just to make, this is where Tahiti is here, okay? Here we have the very well-known island of Bora Bora, and this is a view of Tahiti, and you can see that all the people are along along shore here, because as I said, all the island is nearly inhabited. We have a rainforest here, and all the people are along the coast. So when the wave is coming, you have just the lagoon. That is about 200 to 300 meters to slow down the wave. Okay, so this is a record by the tide gauge in the Tahiti main harbor in Tahiti. So here you can see the wave coming here.
Oh, you have crest leading anyway.
Okay, and there is about 10 minutes between high and low in the oscillations. But this is not a big deal in the Papeete harbor. We have a few tenths of centimeters coming. So we did computer modeling to look at the effect of the wave, because there is a lot of people in this area, so we have to be sure that about the possibility of inundations. So here, this is a Papeete city. I would say it's 100,000 inhabitants here. This is the harbor. This is a levee here to protect the harbor. And you can see that we had only waves no more than 1 meter in the harbor. So it's safe for this respect. But we have also the waves maximum run up all around the island. And in some places along the outlets of some rivers, we had up to 3 meters. And just to show you another hotspot, I would say, Marquesas Island. So the Marquesas are, as I said, on the north of the archipelago. Here we have this island, small island. This is a typical village in the Marquesas. Very few people, 200, 300 people. But they deserve, of course, to have also an alarm system. And you can see it's very flat areas surrounded by huge mountains, up to 1,000 meters in some cases. So it's nearly a trap. Another wonderful image of some valleys. Okay. The village is here. Okay, it's nearly hidden. When the tsunami wave is coming, the water is engulfing into the valley. And this is why they had in the past, we can see on the walls of the mountains traces of tsunami up to 20 meters. Another illustration of the small villages. Oh yeah, it's another life, I would say. Typical habitations. Of course, this cannot be resistant to a tsunami wave. This is observation from the tail gauge station in Nuku'iva. And you can see the wave coming here. And we did also simulations about the impact of the tsunami. And we had in some places up to 4 meters, but I have to go fast because time is running. And here you can have all the run-up computed around the Nuku'iva Island. So as I said, up to 4 to 5 meters. Another observation. And this is a computation for the Otuona village. Just for the information, Goggins is the grave is here. So you have the grave and just and the cemetery, and just in the same village we have the tide gauge. Okay, another observation up to 4 meters. And in a few minutes, I should just speak about another kind of things we have, that is to say the typhoons. So we have a lot, of course, in Taiwan. We have only a typhoon every 4 or 5 years. But they can have also very large impact. This is an example of the last typhoon that we had last year in the Tupuai Island. This is the island here. And the trajectory of the typhoon directly was over Tupuai Island on the February 6. The island is belonging to the Austral Island archipelago. This is some slides about the disaster. We had only 1 person killed. The road around the island was completely destroyed, so we have to rebuild everything. You have here a typical guy from the Tupuai, and the boat was found at 300 meters from the seashore. So we observed this typhoon. You have a new brand tide gauge. I built it, and I put it into service only 1 month before the typhoon. And I assumed that the tide gauge was destroyed, but it was not. The tail gauge received waves up to 8 meters. So here you have, and everything worked. I cannot understand why the tail gauge was not destroyed. So here you have the total zenithal delay here, Here we have the pressure, and this observes the sea level rise about 1.5 meters. Okay, so just to finish, the typhoons in French Polynesia have some very interesting impact on the environment that is not seen, I think, in Asia. There is a presence of ciguatoxin. That is to say, some coral are killed by the typhoon, and thereafter they are colonized by algae. And these algae are eaten by the fish, and they go through the food chain. And at the end, you have the people. And they are very, very toxic algae, and you can be killed with a fraction of a billion of grams by these toxins. That can have a very long standing effect after the cyclones, that is to say 20 years. And just to finish, we have also man-made tsunami, because we know that the French did a lot of nuclear testing in the South Pacific. And in some atolls, for example, this one, this is the Moruoa atoll, and part of the atoll are in risk of collapse. So there is a risk of tsunami on this atoll that is Tureia, only 200 inhabitants. But they can have a tsunami without any warning in a matter of a few tenths of minutes. So to go to the conclusions, French Polynesia is, as I said, one of the most remote and fragile environments. Disaster relief can be complicated due to distances, severe weather, and destruction of airstrips. During the last event, the last early typhoon event, the airstrip was out of usage, so they had to send boats. It took nearly 2 days to reach the island. The cost of protecting those people are very, very high with respect to the number of people. Because when you have to put very complicated measures to only protect 200 people, you have to be certain about the cost. And as I said, we have a very particular effect, that is to say the toxic events that can come just after the typhoons. Okay, and just a nice picture of child in French Polynesia. It's a wonderful place, a very remote place, but we are trying our best to protect our populations.
Thank you. We allow no questions.
I would like to see your sea level gauge data.
The sea
I like
level
to
gauge,
see the time.
for what?
That to show sea level or tsunami. I like to see the time. Oh yeah, you see, but not very clear about the time. Actually, you have to be tide. You filter the oceanographic tide,
Yeah.
and you can see the tsunami.
This is just a raw
And
data.
you start the time from when the earthquake occurs. So, but time should be the UTC.
Yeah, we will do that because I just
And
got.
you know the arrival time of the first tsunami.
But if you are interested in, all these data are on the Hawaii University system, so you can download it if you want. These are just raw data, just to show you what are the records.
Please send us, the website or the university that analyzed it.
Yeah,
This is interesting.
As I said, we are implementing, and at the end we plan to have about 10 gauge stations in French Polynesia. But the difficulty is to maintain that, because when you have to go even to change the battery in some island, we have to go for 1 week, because we have only a flight each week. So thereafter we have to go to the coconuts and wait for the next plane.
You use what tsunami modeling?
Most, I think.
Oh, most. I also use most method of splitting tsunami. Okay, that's good.
One more question.
Are there any island disappeared
Disappeared? What do you
during
mean?
the past few decades? due to
no,
sea level rising?
we have the problems that we have. I will show you. Maybe. Okay. It's here. Because we have two types of island in French Polynesia that we call high island, a very young island, young volcanoes up to 2,000 meters or 1,000 meters. And when the volcano is dying, we have the formation of an atoll. And the maximum altitude of an atoll is 2 to 3 meters. It's very, very low. When there are a typhoon or tsunami coming, when the island is sufficiently big, we have a special protective houses with very huge pillars up to 2 or 3 meters and built in concrete. And also population is gathering on the bunker and wait for the end of the era. But in some cases, we had problems. Here you have the Bellinghausen atoll, Motuhone in Tahiti. And 20 years ago, about 20 or 25 people were killed after a typhoon. They refused to leave the island. The typhoon came, and thereafter, nobody.
I have one question. You mentioned about the satellite laser reflector. It's one of the network. What is the purpose?
The purpose is for climate studies. We are improving the orbits of low Earth satellites, Topex, Poseidon, and so on, because they are observing the sea level by sending radar waves. And so we have to know the orbit of the satellites, to know the distance between the ocean and the center of the Earth. This is the purpose. And we are also doing work to improve the reference frames of the Earth. They are very important to model the climatology effects. So we are at the core of the South Pacific. As I said, a very teeny observatory, but a very important one, because we are constraining the data for about 1/3 of the Pacific.
Thank you. One last question.
Just a question about toxicity, as you said. What is the mechanism or chemistry of that?
I'm not a specialist about that. But when the typhoon is coming, you have the reef is hurt by the waves. So there is a lot of corals that are dead. Okay, and some algae are eating nearly the coral. And they are making by their own biology, this is normal for them, by making some toxins that are very, very powerful and acting on the nervous system of mammals. So they are no impact on the fish. Okay, so the fish are eating the algae, and thereafter the toxin is concentrating from the fishes all along the food chain. And at the end, you have the fisheries in there's a small island. So the fish look normal, but when you are eating the fish, after a few hours, you have an attack on the nervous system, and this can mean you can have very, very severe symptoms, even die.
And how fast does this process keep?
A few months or years.
Even years?
Yeah, that is to say about 20 to 30% of all the islands in French Polynesia, you cannot fish because we have typhoons every 5 or 6 years, and the effect of the typhoon is lasting for 20, 30 years.
Okay, thank you.
One question.
A question?
The algae exist all the time, or and just equal corals because there are more corals?
The algae is normal. It's the dinoflagellae. I'm not so specialist about that. But very often, normally, you have a few dead coral.
Yeah, okay.
When the typhoon is coming, you have a lot of dead coral.
Okay.
This was the reason.
Okay, thanks to Dr. Barriot's excellent and interesting talk. The next speaker is Ms.